Next, we're going to talk about mixtures and pure substances. How could you determine whether an unknown clear liquid is pure water or salt water? You cannot taste it. You should never taste anything in the lab. So, if you can separate the salt from the water by physical means without causing a chemical reaction like a big release of energy with bubbles and gas and like a new substance being formed, then that's a mixture. And if the composition is uniform, like sugar and water or air or stainless steel, we call that a homogeneous mixture. If the composition's not uniform, we call that a heterogeneous mixture. So like granite, where you can really see the individual granite particles, or wood or blood, where it has different components that are not separated, easily separated. So a pure substance um, can be decomposed by ordinary chemical means, like water can be decomposed into hydrogen gas with reactivity and oxygen gas as it reacts with lithium metal and potassium metal. Sodium chloride and sucrose can all be uh, reacted. Sucrose, when we eat food, it reacts with ordinary chemical means. Other ele- other chemicals like gold, aluminum, oxygen, and chlorine need more energy to decompose. So that it's not it's not considered ordinary, where just re- combining them in a container will cause them to react. It requires a lot of extra energy to get these substances here to react. Um, so we would say that no, they're not mixtures. So mixtures that have the same composition or are what we say they're uniform are said to be homogeneous. And we sometimes call them solutions, like when you dissolve sugar, whatever this is, it might be sugar or salt. When you dissolve it in the water, then you have a sugar solution or a salt solution. Mixtures that are not uniform are heterogeneous. You can separate mixtures by many means, and I want you to think, um, how might we separate? How might we separate salt from water? If we have salt water or some kind of thing, how might we try to separate that thing? So we might use filtration, where larger particles um, get blocked by a filter and the smaller particles pass through. Okay, we might use centrifugation, where we separate the solid components in a solution from the liquid by spinning it rapidly for really long time periods until we see the solids that are settling at the bottom of the tube. Uh, Paper chromatography can be used to separate dyes or pigments, and these substances move at different rates on the paper after the same amount of time. We can see the red really separated a lot more rapidly right here than the yellow and the blue. So, how might you separate the salt from water? You should think about that. And then we get to pure substances, which are always homogeneous, and they can be either elements or compounds. Elements are like the most simple substances that we know. They can't get broken down by chemical or physical means. Elements like hydrogen or oxygen or carbon. Right here we see pure sulfur in its yellow powder form. We see iron, powdered iron in its most pure form. No matter how much energy this undergoes, it will not break down further. Compounds are substances with constant composition. They can be broken down into elements, but only by chemical processes like this iron sulfide. To break that down, I'd have to react it with something. I can't use filtration. I can't use spinning it around. I can't heat it up until all the liquid evaporates and I'm left with crystals at the bottom of the glass. So this is what we call a pure substance. So to summarize, we have mixtures and substances, and mixtures we can separate with ordinary means, and substances we can't. We have to use chemical processes for compounds and elements. You'd have to use extraordinary physical means to break them down, like atom smashers or like those high energy tubes that accelerate atoms at extreme velocities and smash them together, and they could separate atoms into their constituent particles. So, yeah, I think that's the end, if I'm not mistaken. Thank you.